Hello students, how are you? In today's video, we are going to learn electric dipole moment. So what is an electric dipole? It's very easy. Two equal and opposite charges separated by a very small distance is called an electric dipole. Two equal and opposite charges separated by a very small distance. This distance is very small indeed, but I am showing this much big only to make you understand. So whenever two equal and opposite charges separated by a very small distance, that is simply one electric dipole. But whenever we learn a new quantity, we have to understand the next step is measuring it, right? So the measurement of electric dipole is the dipole moment, electric dipole moment, and the symbol of electric dipole moment is P. Electric dipole moment P. See, P is equal to what any one of the charge and the multiplied by the distance between them. Let us say distance between these two charges is 2L. So 2L multiplied by Q. This is electric dipole moment. P is equal to 2LQ. Any one of the charge multiplied by the distance between the charge. There's a reason why I took 2L and not L. If you'll ask, in some applications we will take the midpoint, so that easily we can say this part is equal to L, this part also is equal to L, we can say. So keeping that in view, already I have taken the distance between the two charges is 2L, then P is equal to 2LQ. In some numerical, if the distance between the two charges is given to be, let us say 5 mm, then 2L is equal to 5 mm, L is equal to 5 by 2. It will be like that, okay? Now, this is electric dipole moment, but the question is, electric dipole moment is a scalar quantity or a vector quantity? Electric dipole moment is a vector quantity, and if it is a vector quantity, it must be having some direction, and the direction is always from negative to positive, okay? So if I write it vectorially, I have to write it P vector is equal to 2LQ. It looks odd, right? This side, left hand side is a vector and right hand side looks to be a scalar, but there will be a length element. This is stated as a vector quantity which is from negative to positive always. If I take this to be, let us say AB, then A to B. That's the direction of electric dipole, as simple as this. But the question on this will be more on the electric field due to a dipole. Then we'll see the electric field due to a dipole. Let us say case A, electric field due to a dipole along axial line. I'm going to clarify what is axial line, and the second is along equatorial line. Now, suppose the electric dipole is this, let us say minus Q and plus Q are separated by some distance. Let us give some names A, B, and midpoint is O, let us say. Now, due to this dipole, what is the electric field at a point we are going to calculate? And that point, that any point P, one application is if the P is along axial line, and one application is equatorial line. What is axial line? If we join the line joining the two charges is called the axial line of the dipole, and the line perpendicular to the axial line and passing through the midpoint of the dipole is called the equatorial line. This is axial line and this is called equatorial line. Now we understood the basics, right? Then, well, let us say that this is the dipole, minus Q plus Q charge is there, and this is the midpoint. Let us give some names. The dipole is AB and the midpoint is O. Now, the first application is along axial line. So, along the axial line, somewhere, let us say the point P is there here. Let us say. Now, what we are going to find out? The electric field at point P electric field at any point. Okay, the electric field at point P due to the electric dipole along the axial line. This is we are going to find out. So what we'll do, what is electric field? I'm just reminding from last session. What is electric field? It is the field, it is the force experienced by a unit positive charge. Yes or no? So you imagine that there is one unit positive charge placed at a P. Then what is the force experienced by B and what is the force experienced by A? By P, this unit positive charge experiences two forces due to B. Let us say we are writing it as F P due to B, and why I showed this side, this is plus, so it will be repulsive, so P will be pushed by B, right? What is because of A, this is plus, this is minus, so because of A, P will be pulled in this direction, right? So the force is FP due to A is this side. Between FPB and FPA, which will be bigger? Apply your common sense. See, this is the force between Q and P, Q and plus 1, and this also is the force between Q and plus 1 only. So the magnitudes of force should be same or not? It is not same, because according to Coulomb's law, what we said is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q1 Q2 by R square. What is the force according to Coulomb's law? 1 by 4 pi epsilon naught, whatever the charges we are taking, divided by the square of the distance between them. Now when you are finding the force at P due to B, then your distance is this much only, distance between the charges. Where you are calculating FPA, the distance between P and A is this much. If distance in the square of the distance which is in the denominator, that means if R is more, F will be less, so FPA will be less than FPB. You got or not? FPB must be more than FPA. You got or not? I have to erase it. If you didn't get it, pause the video or go a little back and listen to the explanation once again. So to write, I have to erase it. Now see, FPB is equal to how much? FPB is equal to, see, when we say how much, then that what is the distance we should know, right? We will assume that, let us say, the distance between AB, this is 2L we are taking already, right? So that we can take easily the distance from O to B is L and the distance from A to A is L, right? Now what is the distance of a point P from the dipole? When we say from the dipole, it is always from the midpoint of the dipole. Let us say the distance of the point from the midpole of the dipole is R. Fine. Now what we are calculating, FPB. FPB is equal to 1 by 4 pi epsilon naught Q1 Q2, so plus Q by R square, B square, right? Let me write PB square only and we will replace that R minus L whenever is required. And what is FPA? FPA is equal to 1 by 4 pi epsilon naught Q1 Q2, this is minus Q, right? So it is attractive in nature. We are writing the magnitudes only, so plus or minus we are not considering, but when we will add them, we will consider the signs then. Clear? So FPA is equal to 1 by 4 pi epsilon naught Q1 Q2. Again this is Q only, but R square, what is the R between the two here? AP square, right? Fine. Now between FPB and FPA, FPB is greater. This I have explained why, right? Therefore I am writing FP, the net force on FP, the net force on the unit positive charge placed at P. For that I am writing FP is equal to, can I say FPB minus FPA is equal to, FPB we have, FPA we have, just you just dictate. Oh, you cannot dictate. Okay, I am writing 1 by 4 pi. This should go in your mind along with me. Along with me means before I am writing you should be saying it. Okay, 1 by 4 pi epsilon naught Q, you take out, 1 by PB square minus 1 by PA square. PA square. AP is the same as PA, right? PA square. Just it looks good. That's why I wrote PA for AP here. It's the same thing. Now is equal to 1 by 4 pi epsilon naught Q multiplied by 1 by PB. PB is equal to how much? Now you say, isn't it R minus L? R minus L whole square minus 1 by PA. Isn't it R plus L? From here to here L, from here to here R. R plus L whole square is equal to 1 by 4 pi epsilon naught Q. Take LCM R plus L into R minus L. The formula you know, A plus B into A minus B is A square minus B square. So R square minus L square whole square. R plus L whole square multiplied by R minus L whole square. So R square minus L square whole square. And this is R plus L whole square minus R minus L whole square. Isn't it? And the top, A plus B whole square minus A minus B whole square. You know that A plus B whole square minus A minus B whole square is equal to 4AB. So from there, I am writing, how should I write here? Is this visible? Here only I am writing that. 1 by 4 pi epsilon naught Q into this is 4RL divided by R fourth. See, instead of R square minus L square, I wrote R fourth. R fourth. Why? Since, see, just to make you understand, I have showed this 2L to be this much big, but actually it's negligibly small. Since L is very small than R, L can be neglected as compared to R square. L square can be neglected as compared to R square. That's why I just considered this entire thing to be R square only. And R square's square, that means R fourth. 4RL by R fourth. So 1 R gone, this becomes R cube, right? So from this line, I am writing here. See, therefore F is equal to, Fp is equal to, what is it? 1 by 4 pi epsilon naught. I am writing below 1 by 4 pi epsilon naught Q. See, this is 4RL. So can't I write that as 2 into 2? I think. See, 2 into 2 I kept a 2QL and 1 R got cancelled by R fourth was there, RQ it became. Right. Why I did this? 2QL we have already calculated that the dipole moment P, you remember. So this is equal, therefore this FP, this force, since this force is on a unit positive charge, what we can say, this is nothing but a E. Therefore E is equal to, EP is equal to 1 by 4 pi epsilon naught 2P by RQ, where P is equal to 2QL, dipole moment we have studied already, right? So this is the expression for electric field due to a dipole, electric field at any point P due to a dipole along the axial line. Any question till now? I hope it's very clearly understood. And in exactly similar fashion, we will be taking the electric field due to a dipole along the equatorial line. Okay, now we are finding the same electric field due to a dipole at any point along the equatorial line. Now equatorial line means, let us say R minus Q is here, plus Q is here, and the midpoint is here. O. Let us say this is A, this is B, this is O. Now what is the equatorial line? Perpendicular to this, perpendicular to the dipole and through the midpoint of the dipole is the equatorial line. So along this line somewhere there is that a point P is there. What we are going to find here? Electric field at point P due to the dipole along the equatorial line. Fine. So again, to find the electric field, you imagine a unit positive charge at P. Then what force that will experience due to B? F P due to B. Now, why I showed in this direction? Because don't you think that it will be repulsive in nature, plus plus, so it will be repulsive in nature. But the force due to A will be attractive in nature. It will be attracted, right? It is minus plus, so it will be attracted. So this is the force P. Now what we'll do, since these forces are on unit positive charge, so we can take this E, electric field at P due to B, this electric field at P due to A. And while finding out the resultant of those two vectors, so what we can do is, see, if we take this angle theta, if we assume, then don't you think that this angle will be theta? Why? Alternate angles. And since this is the midpoint, if this is theta, this also will be theta. And if this is theta, this also will be theta. Why? This and this are alternate angles. So basically this is a divider of a half. This angle becomes halfway. Now I'll show with a different color. Now see, this FPB can be resolved into two components. Now see, before writing FPB, EPB, EPA all the time, so we can shorten it. Now see, this entire length we said 2L, or simply one length is L and this side also is L, right? And the distance of the point from the dipole is R. So in this case, this much is R. PO is equal to R. Then what is PB? Don't you think that it is R square plus L square, because this is a right angle triangle. So PB is equal to root under R square plus L square. Similarly, PA also root under R square plus L square. PA also. Is it clear? Now see, what is EPB? Isn't it equal to 1 by 4 pi epsilon naught? 1 by 4 pi epsilon naught. Q1, Q2. Here at P plus 1 you have imagined. So Q by R square plus L square, isn't it? Now what is EPA? Don't you think that that is also 1 by 4 pi epsilon naught Q only, between these two Q, only because of minus, the direction is different, but the magnitude is same only. Q by R square, the same R. Don't you think that the magnitude will be same only? So let us write this to be also E and this also to be E. Means the magnitude of a EPB is equal to E, the magnitude of a EPA also is E. Okay. Now, so that our mentioning becomes very easy. This E, now this is E, this also is E. E in this direction, E in this direction. Okay. This E can be resolved into two components. Yes or no? See, a component. Here is a component. This, since this is theta, this is E cos theta, and this is E sin theta. Similarly, this E also can be resolved into two components. One is downward, which is E sin theta, E sin theta, and one is towards this, which is equal to E cos theta again. So E cos theta was there, another E cos theta is there. So don't you think that that became 2E cos theta along this direction? And this E sin theta and E sin theta are equal in magnitude in the opposite in direction. That's why they will be cancelling out each other. So the net electric field at P is towards west, or not, let us not say west or something like that. It is horizontal to the dipole and towards the left, and by magnitude it is equal to 2E cos theta. Therefore E is equal to 2E cos theta, 1 by, for E I am writing 4 pi epsilon naught Q1 Q2, Q and 1, Q by R square. R square is what? The distance, square of the distance between them, and square of root under R square plus L square is simply R square plus L square. So this is what? 2E. 2 we have written, E we have written. multiplied by cos theta. How much is cos theta? You take any one triangle. Let us take the triangle PAO. This triangle you consider PAO. This triangle. In this, cos theta is equal to how much? Isn't it B by H? So this much is L. L by root under R square plus L square. Is it clear? So this is equal to nothing but see 2QL. I can keep aside 1 by 4 pi epsilon naught. Okay, 2QL I have kept in one row, and this is R square plus L square to the power 3 by 2. You got it? R square plus L square to the power 1 and R square multiplied by R square plus L square to the power half. So 1 plus half is 3 by 2. Got it? Now, since again we'll apply that idea that this L is very small as compared to R. Only I have shown this much big to make you understand, but it is very small in fact. Why very small? Only when the distance between the two opposite charges is very small, then only we define this to be an electric dipole. Now, since L is very small than R, we can neglect L square as compared to R square. So directly we can take this as only R square only. Then 2 gone, this became R cube. Therefore, implies that E is equal to, then 2QL is the dipole moment, remember? So 1 by 4 pi epsilon naught P by R cube. This why it became R cube, because L we removed, R square to the power 3 by 2 R cube it became. So what is the difference? In A we found out the electric field due to a dipole along the equatorial line. There E is equal to 1 by 4 pi epsilon naught 2P by R cube came. Here along the equatorial line it is just E is equal to 1 by 4 pi epsilon 0 P by R cube. So the electric field along the equatorial line is a half of that along the axial line, provided the point is at the same distance from the dipole. Fine? Is it very clear? We will take up one simple numerical. Well, pause and note down the question. The question says, an electric dipole consists of two charges of 16 microcoulomb and minus 16 microcoulomb separated 5 into 10 to the minus 3 meter apart. Calculate two parts of the question. Electric dipole moment is the first part. Second part is calculate electric intensity at a point 0.2 meter distant from the center of the dipole. In that bit also there are two sub bits. Once calculate along the axis, along the axial line and along the equatorial line. Now you take down the question. Now I am going to explain this, and for that I am erasing it. I hope you have copied it, and if you didn't do, you pause the video and copy the question first. Now it says an electric dipole consists of two charges, minus 16 microcoulomb and plus 16 microcoulomb. Minus 16 microcoulomb and plus 16 microcoulomb. Separated by a distance. This distance is given. Separated by a distance. How much? 5 into 10 to the power minus 3 meter is the distance. Calculate the electric dipole moment. It's simple. First bit is calculate the electric dipole moment. That is P is equal to how much is the question. So P is equal to what? 2L you know, is equal to 2L. 2L length is given 5 into 10 to the minus 3 into Q, any one Q. 16 microcoulomb means 16 into 10 to the power minus 6 coulomb. All the units we have to keep in SI units we should maintain, right? So this is equal to how much? 80 into 10 to the power minus 9. So 80 into 10 to the power minus 9. What's the unit? What's the unit of P? See, it's a 2L is there, which is meter, Q is there, charge is there, coulomb. So coulomb meter. Now this is very simple, but answer to the next bit we are calculating now. Now the next question is calculate the electric intensity at a point at a distance of 0.2 meter from the center. 0.2 meter. Now from the center, if we'll give this A, this B and this O, from the center at 0.2 meter apart, that 0.2 meter in one bit it says along the axis axial line and along the equator, that's the equatorial line. So here if we keep at a distance of 0.2 meter, 0.2 meter, this is the first subbit of a bit 2 also, of 2 also, as axial line. See, now the entire derivation we have done, I need not explain that once again. I can just put the formula and get the answer kind of thing. For getting the concept behind it, you can rewind the video and you can watch it again and again as much times as you require. Now axial line, what was the formula? Dictate please. Okay, you cannot dictate in a video. 1 by 4 pi epsilon naught, it was 2p by r cube. You remember? E along the axial line, E is equal to this much. So this is equal to 1 by 4 pi epsilon naught 2p. 2 into p is equal to what again? Dipole moment 2lq. 2lq somewhere we had calculated, right? Previously I have erased that thing. The answer was 8 into 10 to the minus 8. So p, I am writing the p came 8 into 10 to the power minus 8 coulomb meter was p. Now here what will happen? 1 by 4 pi epsilon is 2 into p. 2 into that 8 into 10 to the minus 8. 2p by cube of r. R is given to be 0.2 meter. Cube of 0.2 meter means 2 into 10 to the minus 1 meter. So 2 into 2 into 2 cube into 10 to the power minus 3, right? So this is equal to, for 1 by 4 pi epsilon 0, you can put 9 into 10 to the power 9 multiplied by 2 into 10 to the power minus 5. So this is equal to 18 into 10 to the power 4. What's the unit? Newton, right? Now this is the axial line thing, and the second bit of 2 is along the equatorial line. Then simply what we'll do, then in that case again I am erasing it along equatorial line. E along equatorial line is given by E is equal to 1 by 4 pi epsilon naught p by r cube, right? Is equal to, therefore E is equal to 9 into 10 to the power 9 into p. P was calculated 8 into 10 to the power minus 8 by r cube. 2 into 2 into 2 into 10 to the minus 3 is equal to 9. 8 got cancelled. 9 into 10 to the 9, this is minus by 10 to the 4. Got it, right? Okay. Is it clear till now? Thank you.